Okay, hi everyone. So this is the last computer practical I'll do with you, and then obviously Ian will do another two. So we slowly built up in complexity. We started with a relatively simple one, looking at Hurricane Sandy. Then we looked at monthly mean sea levels from the Permanent Service for Mean Sea Level. Then we looked at kind of hourly data from the University of Hawaii and did a tidal analysis. Well, today we're going to look at high frequency data as well from Portsmouth in England, much closer to home. Okay, so first of all, navigate to your folder. So we've got this SOES Practical folder, and then go to Practical4. And like we've done in the past, I would set up a data folder, a mat files folder. Let me just remind myself what else, a figs folder. Now, within the data folder, we're actually going to set up two folders. We're going to set up a projection. So today we're actually going to look at sea level projections, and we'll set up another folder called TG for tide gauge. Now, always try and make this generic. So here I'm going to put tide gauge site, PTM, which stands for Portsmouth. But if we're only going to look at Portsmouth, but we could easily do this for all 43 tide gauge sites. Okay, so that's got us set up. So let's go into MATLAB. I typically always do this, although I haven't done it in this order before, but I always start with a README. It's just really good practice to do it. And today I'm going to jump straight in and do it. So we're going to start with a Control1. Sorry, my screen seemed to be locking up, don't know why. So we'll start with a Control1. Now this time it's a little bit different, but let's start with this Control1. So February 2021, this M file, clear. Now what I want to do with this M file is gonna load in tide gauge data from the BODC for multiple years. Okay, and then step one is to load in the data. So we're going to load in the data, and then I'm going to jump ahead after the loading in data. We're going to plot the data, and sometimes I find it useful before I've done any coding is just to kind of lay out the steps, because it kind of helps me to think logically what I need to do. And then after that, I'm going to save the data to a mat file so that we can call it in other controls. So that's saved as a capital for some reason. I'm just going to save it as a lowercase. Okay, now let's go to the British Oceanographic Data website. So bodc.ac.uk. Now, first of all, you need to log in up in this top right corner. I've already logged in, and the first time you do this, you'll need to register. But once you've registered, you can go to Search Data, UK Tide Gauge Network. Okay, and here is the tide gauge network. So here are the sites. Let's zoom back in. Here are the sites around the UK, and there's 43 tide gauge sites. Now what I'm going to do is, there's lots of different ways to do this, but I'm going to download the annual and monthly files, and they're available. They're normally a month behind quality controlled. Okay, so we're going to download quality controlled tide gauge data. So we'll click on that. Now, there's different ways to do it, but I prefer this form-based selection tool on the right. I find that the easiest to do. So let's click on that. Okay, now with this form-based tool, you can just click on all of the sites. So you can download all of the data in one go if you want, but let's just do Portsmouth. And we are going to do the primary channel. We're going to do values and residuals. Let's do this first column. And I am going to tick all of the years. So each year is going to come in a separate file. Okay, then we can upgrade request. Okay, so those are all of the years, and then we can click request data now. Okay, you have to put in some details. So research funding, I've put none. You accept the terms and then download now. Now, sometimes, depending on how much, sometimes it could take up to 10 minutes to download the data, but this should be quite quick because we're only downloading one site. Okay, so I can go back to my folder here, check in the downloads, and there is the data. So I'm going to copy it into T, and you can see it's got a 3-digit code, PTM. Okay, I'm going to copy all of those files across. And you can see that there is this HTML, which we can open in a web browser. Doesn't seem to be working for some reason, but that normally contains information about the site. I don't know why that's not working. But there's details about the kind of format of the data. But we can click on here and go to edit. We can have a look at the data. In fact, I'll drag this up here so we can see that it's a bit of an odd format, but essentially you've got 11 header lines, then you've got a number, the date, time, and this is the total water level. That's obviously a default value. Then you've got the storm surge component, the residual as well, and it's got a letter, which is a bit of a pain, but the letter tells you whether it's a bad data set or good data set, and we'll come back and have a look at that in a minute. Now, because the data is in years, rather than loading in here, I'm actually going to create a new MATLAB script called loadin, which will just work for 1 year. So let's call that loadin1. So this is just going to work for 1 year. I'm then going to turn this into a function and call it 20 odd times to load in all of the data sets. Now, always, I'm going to try and make this generic so that in this practical, we're only going to look at Portsmouth, but if you wanted to, you could do this for all of the sites. Let's look at a year. Let's just do a random year, 2004. And again, I'm going to do a figure because if I call this 20 odd times, I don't want it to produce the figure every time. Okay, so the first thing we'll do is create the file name, file in. And I'm going to add bits of string together. So it's within the data folder. Then we have the tide gauge folder. And then within that, we have a folder called Portsmouth. So we have a SID there. Okay, we can go back here and have a look, or we can have a look here. Okay, then we have a year. So I just need to convert that from a number to a string. We've got the number to string year. Then we have SID again, which is Portsmouth, and then we have .txt. So again, let's run this and just check that it's producing the right file name. So data, tide gauge, PTM, 2004. And obviously if we change this to 2005, it should change the file name. Okay, now this data is a little bit more complicated to load in. And it's a bit of a, so let's start with 2004. Okay, so what I'm going to do is, first of all, the first column is a counter. Then there's a year, month, day, hour, minute, second. Then we have the water level, and then we have a flag. I'm going to call that F1. Then we have a surge, and then we have a flag 2. Now, because this data is quite a strange format, in fact, let's drag in 2004, because that's the one we're loading in to start with. Because it's got header lines and circular brackets, the load function won't work. So we need to specify our own way of doing this. And the nice thing about MATLAB is there's this thing called text read, and you give it the file in, and I'm going to put 3 lines to get it onto the next line of code. And now we can specify the format. And the format is, this is will be new to quite a lot of you, but essentially the percentage sign is a column. So percentage D, and D is, I don't know why they put it D, but D is a integer. So the first column of data is an integer, and then there's this funny little circle. Then we have the year with a line, then we have the month, then we have the day, then we have the hour, minute, second. Oh, but these are separated by by colons. Okay, and then we have the data, which is what's called a floating number. It's got a decimal place. And I've checked this out before, but there's kind of 8 columns of data. So there's 5 points of data, then there's a data point, then there's 3 decimal places, or 4. The decimal point counts for 1, 5, and then 3 decimal places. Now, I do appreciate that's a bit confusing. Then we have a string, a column of numbers, a column of letters, which is a flag, and there's 3 letters, an M, which stands for improbable, a null value, which is an N. So there's an M and an N. And then we have that all over again for the surge time series. So just going back to the data set again. So you can see that we have that circular brackets, day, that, and then we have this kind of 8-digit number, 8 characters, another 8, and then 1 letter. Sometimes the letter's there, sometimes it's missing, but it's a really annoying format and it takes a while to read. And then we have header lines, and we have 11 header lines to ignore. And then what I will do is I'll say TS, because I've loaded them all in separately, I need to convert them to a date num. So it's the year, month, day, hour, minute, second. And then I can get rid of those. Clear year, month, day, hour, minute, seconds. I'm also going to clear the counter because we don't really need that. And then I'm going to convert this to a date time variable, which is just much easier for the plotting. Convert from, and it is a date num. Okay, so let's check if this works. Okay, badly formatted specifying. So something's not quite right here. So let's just go back and check. So we have counter, year, month, day, hour, minute, seconds, water level, flag 1, SU, flag 2. We have text read. So we have that. Oh, here's this D. I'll put it as a capital. It should be lowercase. Okay, so now you can see it's loaded in all the data. And this is 15-minute data. So, and 2004 is a leap year, so it's 366 times 24, and there's 4 every hour. Yeah, so you can see it's the correct number of digits because it's 15 minutes, that's 4 every hour. Okay, now the next thing we're going to do is remove the flags, because the BODC quality control the data. Remember, data reduction. So they have these 3 flags. So if we go back to the data here, they have an M and an N. And if you look at the format file here, I think it's in the format, it tells you what those are. Now, I've used them a lot. So here they have an M, N, and a T. So they have the M values, which are improbable, so we don't want to use those. They have the N values, which are 999, we don't want to use those. T is interpolated is fine. So we will use those. We can always bring that back in here just to remind ourselves. Okay, so let's start with the improbable values. So what we're going to say is I1 is find, and we do string CMP, and we're going to find the flag 1 that is equal to M. So remember we had this flag 1. And equal to M. Now it seems to have picked up an extra value in there. So let's just make sure that that's defined as 1 and 1. Let's run that again. Did I call that F1? Let me just change this to 4. I might have the wrong number here. Yep, that's working now when you change that to 4. I must have got the digits wrong. Okay, and now you can see that it said rows 1 to 8 and 100 and 101 are these M's. That's really good. Okay, now we want to get rid of that data. So the water level I1, we're going to call these NaN, and the surge I1, we're going to call NaN because we don't want to use those values. And then we can copy this again, and the next one is a null value. So the null value is F2, and this has an N. And I appreciate that this is probably confusing, but it's really useful when the data's been quality controlled and you don't have to do it. So let's get rid of all of these variables. Let's clear the variables that we don't want. So now that we've used them, we don't want I1, we don't want I2. We don't need the flags anymore. Okay, so let's run that. And you'll see later on it's cleared all of those variables. Now that we've done that, for some reason the BODC data doesn't give you the tide, it just gives you the surge, but we know that the tide is the water level minus the surge. Okay, and now that we've got all that, we can plot the data. Again, I'm going to use this switch function, switch fig, case yes, to plot the data, because when I'm doing it in this format, I do want to plot the data, but if I run this for every year, I don't want it to have to produce a figure for every year, as long as I've checked it. Okay, so let's do figures, as always, units normalized, position, and we're going to do 0.1, 0.1, 0.8, 0.8, that's just by default. We are going to have 3 subplots here, so it's 3 columns, 1 row, column 1. We're going to hold on, and the first thing I'm going to do is plot TS2 against the water level as a blue line, line width 2. Okay, then we want an X or a Y label, which is level, meters. Again, always do font weight bold to make it look nice, and by default I always set these as 18. It looks quite nice on my screen. I'm going to set A1 as being font weight bold, font size 16. That's just the labels, make them bigger. I'm going to put a box on, I'm going to put a grid, and I'm going to add a title as well. And the title is going to be, whoops, the title is going to be A total water level. So let's just make sure that works. Okay, that works. Yeah, you can see there's some missing data there. If we had switched these off and we didn't use the flags, you'll see that it will, oh yeah, you can see that that data is missing. It's got null values. There's some bad data there. So it shows you why it's a good thing to trust the BOD flags. Okay, I'm going to copy this line again, A2, A2. Here I'm going to plot the tide as red. So this is going to be the astronomical tide, B, and then that needs to be 2, and then I'm going to copy it again, and this is going to be 3, and this is going to be the surge, or the non-tidal residual, which mainly contains the surge. And the surge, let's plot as green. Now, I never ever like the MATLAB green. It's a bit too bright and it doesn't look good in presentations. So I'm going to plot it as a slightly darker green. And there you go. So you can see a nice big surge occurring there. You can zoom in and have a look at it. Okay, so far we've loaded in 1 year of data, but it's always good to check another year, just make sure it works, 2008. And you can see here, this one has almost no missing data, which is good. And let's try a 2003, for example. And that has worked. Let's do a 2000. And let's just see what the first year is. 1991. And that seemed to have worked. Brilliant. Okay, so we're well on our way now. Okay, now we've got this to work, we need to convert this into a function. So remember, we have our outputs up the top here. So we want the time, we want the water level, we want the tide and the surge. And I'm going to call this load in 1, and it's going to load in the SID. The year is the input, and the fig. And I can turn this off here. You always must turn this off, or else it will just overwrite and load in the same year every time. Okay, so we can go back to control 1 now, and we are going to call this function now for all of the years between 1991. Now what I'm going to do is I'm going to make these lowercase just to distinguish them. And this is just a clever little trick, but I'm going to first of all set up some empty matrices for each of these 4 things. Okay, and then we're going to do it in a loop. For year is 1991 to 2019. Oh, actually, we can do it 2020. Indent that and end. Okay, and the year is going to come in here. Now, the figure I want to be no, because I don't want it to create a figure each time. Now, if I ran this, it would overload each of these each time. So what I'm going to say is TS is going to be the original TS plus the little ts. So this is kind of like it adds it to the end each time. So it kind of appends each one to the end of the matrices. So it's just a clever way of kind of adding things onto the end, so that rather than just having 1 year, we'll end up with a matrices that is all of the years in one, which is what we want. So this is just, it's a quite a bit hard work, but essentially what we'll end up with, and we can delete the small ones each time so we don't overwrite it. So let's run that. It's got a bit confused because I think I saved it as a capital. Okay, I didn't define the SID up the top. I think it's getting confused because I saved it as a capital. I'm just going to save this as something else. I'm just going to save it as Control-2. And then I'm going to go back and just delete. It's getting confused because it thinks it's a capital. So I'm just going to delete Control-1. Delete Control-1. And then I'm going to save this as Control-1 again, but lowercase. Don't quite know why MATLAB does that. Okay, now what I could do actually is put in a Y there. I'm just going to crash this. I'm going to run it up, put in that so it kind of prints it to the screen so I know what year. So you can see it's looping through and it's loading in all of the years. Okay, now what I'm going to do is I'm now going to plot all of the data, and I'm actually going to nick this code because we can just edit it. Now I'm also going to nick this TS because now we have a long TS. So I'm going to change that to TS2, which is the time, changing from a date num to a time. Okay, so we should be able to just use that exact code again. So let's run that now. And now you can see I've loaded in the whole data set, so all the way from 1991. So even though the data was in a bit of a pain, you can see it's been relatively easy for me to load it in. Now, what did I do with the surge? I seem to have made a mistake here. Oh, I forgot to copy in the surge. I could tell it was not right. So let's just run that all again. Okay, so now you can see we've got all of the data, which is looking good. And then the last thing I'm going to do is, again, I really like to break the code down into little bits. I'm going to save this matrices, and I want to save the TS, I want to save the TS2 for later, I want to save the water level, the tide, and I want to save the surge. And again, to make this generic, just in case you did want to do it for other sites, I'm going to save it into map files, and I'm going to add on the SID, and I'm going to save it as a mat file. So we can run the whole thing right from scratch. So you can see this really hasn't taken long, but already in Excel, imagine you had to load in each of those, it would take ages. You can see now MATLAB's in a couple of seconds, it's loaded in, you know, a whole time series of data sets. And hopefully now, if we go to our map file, it's loaded in there. So when I set up a control 2 to do the next bit of analysis, I can just call this rather than having to wait. Okay, so that's the end of the first part.